I'm Danica Pine. I am a developer advocate at Confluent, and I built this panel because I wanted it. This is the panel that I would have wanted to attend when I was first assessing streaming technologies, right? So the whole idea here is that if you're looking to get into stream processing, which stream processing technology should you use? Okay, or and then what should be more aligned with the use case that I actually have to find? Is that us? Fun. There's so many mics in this room now. All right, so I have welcomed 4 stream processing technologies experts to represent those technologies here today, and we're going to see if we can help you decide. Okay, so you're at least a little more informed when you go to build your next application. Okay, so we're going to go down the line and have some introductions. So what is your name, what is your role, and what is your streaming technology that you're representing here today?
My name is Maury. Hi, everyone. And I'm a software engineer at Confluent. And I'm super proud to represent Apache Flink today as my streaming technology.
Yeah, the mics.
Hi.
Can we show the slides, please?
Check.
And then I review the way results.
I think you want it.
Yeah.
Yep. So my name's Gordon. I'm a software engineer.
There we go.
Right.
Yeah.
No.
Oh, really? I'm on?
Just
See the car wanted it.
it'll work.
Oh, okay. Yeah, I'm a software engineer at Confluent, and I'm super proud to be able to represent Apache Flink today. And, there's a bunch of other Flink emitters and PMC members that will come. Each of them technically huge projects. Each of them have specific expertise in project. So I'm happy to represent Flink and talk about my perspective. Yes.
All right. Is your mic live?
Well, I'm pretty sure. We're good at hardware. Here? Yep.
Great.
I'm Cole. I work with Apache Spark, committer and POC member. Worked on it for about a decade. I work at Netflix right now. I need to write software. Highly recommend. That's pretty great. I don't know if there's any Spark to get down. It's fine. I can hang out. I think EB Spark might not be as well as some others used.
We're glad to have you. Thanks.
I feel I'm your XTLB and I'm co-creator of Apache Pulsar, Apache chair. Was many years that I came here.
Hey, I'm Sophie. I'm the founder and engineer responsive right now. We're kind of working on the managed Kafka Streams platform. Obviously, I'm here to represent Kafka Streams. We're on the PMC, so but a lot of projects are on there. A lot of people. Before that, I was at Confluent for a while. I was curious of that. Great. All right, so this is a panel style session, right? Obviously, but this one's kind of unique in that we're comparing and contrasting, and I want everybody to have their opportunity to really lay out their technology for you. So I have given everybody 2 minutes. You get 2 minutes. We're going to go in the line, and so Gordon, will you please tell us about Flink? Give us your 2-minute blurb.
2 minutes.
Yeah, that's all you get.
2 minutes. Okay. So I'll say I'll probably start with Apache Flink is a general purpose distributed computation engine that allows you to do stateful computations for web data streams. Now, that's probably a bit generic because that so all of our stream assistants here on stage here today can rightfully say the same thing from your tagline. But let me try to unwrap that a little bit and what makes Flink different so far.
Can we check his mic, please?
8-year-old.
The timer is burning.
There's so many things going on here. Yeah, we'll leave it. Yeah, can you turn on the mic, please?
Sports.
Nice.
Case. Let's check.
All right. Is that mean yours is working now? Is yours working now?
No.
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 Cool.
Yeah.
Now, can we get on the tab, please, and turn off the lights?
Cool.
has triggers.
Okay. So,
Can we turn it on?
check. Hello? Nope.
Not yet.
Hello? Okay, here we go. Where did we go? Okay.
Take the stage.
So, as I was saying, Apache Flink is a general purpose distributed processing engine for stateful computations and like lines. Now, the first thing I said with stateful computation it says stream processing of data. And I'm trying to emphasize this because Flink is able to do stream processing, batch processing, data actually full workloads, which sometimes can be complex enough that it becomes multi-stage executions and shuffles around the whole query. And Flink is able to do that for over a unified stream execution engine. And probably the second bit that I wanted to unwrap how the general purpose part in my tagline there. The general purpose part, we were talking about if they could stream processing, batch processing, data analytics. But also, its general purpose in the fact that it can process data streams that come from various different sources, file systems, CDC from databases, and also, obviously, distributed demos like Pulsar and Kafka. And it's also the same on the writing side. After processing its results, writes it to all those different source data external systems or a combination of those, and does that using checkpointing with the virus after one's brain sees. I know that I'll be almost up to here in a log. I can publish with the value of those a bit after this. Yeah. Cool.
Fantastic. So yeah, I'm talking about Spark, maybe different logo.
Well, this is what you've got.
Yeah, okay. This is Sparky the Bear enjoying a nice breakfast. Just 2013, 2014, it says 2013 on the shirt, not super sure. Did not make it as the logo despite my best efforts. Cooler heads prevailed, but I think Sparky the Bear is pretty cool still. So besides having a cool bear, Spark is also a general purpose distributed system, which can do stateful processing on streams and batch and all of the sorts of other things. I think a lot of what makes sense when thinking about Spark, Flink, and this is my bias, of course, and you'll probably disagree with me, but I don't have the microphone right now, is that essentially Spark and Flink got to similar places starting from different approaches. And Spark sort of came from the batch world and bolted streaming on top, sort of like, I don't know, putting LED lights on a 1960 VW Bug. So all kinds of fun. But we both, have LED lights at this point, right? Slightly different engines and different focuses. A lot of Spark things are going to explode unexpectedly in streaming, because that's not the first place that the developers are thinking. But if you stick to the things that are like safe for streaming, it's very happy, very similar. JVM based, Scala, all kinds of fun. If you like functional programming, we both have functional APIs. I love functional programming. I think it's a really great way to think about stream processing and data processing in general. SQL is okay too, but I love the functional APIs that they have. And it's all kinds of fun. Generally, I think Spark is a little bit cheaper to run. And that's because we have slightly different focuses, but we're also generally a little slower. And that's probably...
You were at 2. That was perfect. All right. Next up.
So Pulsar is kind of like the outlier here, and we see that we're not just computing, but mostly, first and foremost, we are in file messaging to the platform. That means that we have messaging APIs, we have storage, and we also have so we have multiple overlaps with Apache Kafka, of course. We also have a feature that Apache Kafka does not provide, and it's always potential of regional. But given that we are talking about multi-compute here, we also had the number of years on the compute for Pulsar, and it was that we don't compete with Flink and Spark. They're doing very fine things and very complex things at the very large scale. They're really doing like we were doing that in one, those way. So we're starting to focus on how can we can we have user that is in Pulsar take advantage of the data they have in Pulsar topics, and we can replace the flow of using Pulsar functions, which is more like a stateless functions that you can deploy, which is, of course, it's not, you can do like tenant stages 5 times that, but if you do a single DL, single analytics, you can do that with Pulsar functions.
Thanks. Awesome. I was going to say that when the subject of WordPress, I also failed to put our core ML mascot into our official logo. So that's our unofficial logo. I also thought that I failed to provide a slide of it, so thank you guys for covering my bases there. Yep. Good choice. Kafka Streams. I think we can keep this pretty short. A lot of people here are familiar with it, and also, it is a Java library for running your stream processing applications on your data that's in Kafka. So, really, it was simple to write, especially to our program data is already in Kafka, which follows a general kind of read, process, write pattern built on top of a plain consumer producer client. It's very powerful in a high-level BSL or all the usual stream processing of things like aggregations and joins, and then there's just a low-level processor API that you can use to build your topology, load that down. But overall, it's a lightweight library. You can run it in your phone, you can run it on your laptop. Super easy to get it up and running, get it started, and do some fun with what's going on in Kotlin.
Great.
All right, and so if you can keep the mic, actually. So thank you for those, high-level introductions. I hope everyone appreciated those. But so I want to head in a slightly different direction. I want to have even more context, and you're going to get a history lesson, okay? I'm so sorry if you're not here for history, but I think it's good to be informed in this way. So of these 4 technologies, Kafka Streams has been around for the longest, even when you account for the fact that it was added, not originally to Kafka, with the earliest version of it, but it was 0.10. Yeah. So Sophie, can you speak to the landscape at that time, and the driving factors behind the creation of Kafka, and then subsequently Kafka Streams?
For sure. I can't speak to it personally because I'm on the board over time.
Yeah. It's not that. But I'll start with Kafka. I'll keep this short because I think a lot of people know how Kafka came about and probably were there to witness the pain that was the word for Kafka. Me kind of having come onto the scene after Kafka was already a thing. I always remember thinking at first that, why is this product? Why isn't this just the way that it is already? But before that, it was developed at LinkedIn, and we were just kind of reaching the limit of scale when they had all those kind of producer and consumer patterns. But it's just really impossible to scale it up to the full business where you have a bunch of different teams all try to synchronously or asynchronously write and read and just kind of share data throughout an entire company as opposed to just having an interface between each team to each other team, which really goes out of hand frequently. So for that Kafka work, everyone knows it started at LinkedIn, and then it really became apparent that it's solving a real world problem that a lot of different companies were having. And then, that's the history of Confluent and all these conferences, which we all love. Kafka Streams came a little bit after Kafka itself. Really, we were kind of noticing that a lot of people were basically building their own kind of custom homegrown producer, consumer, client apps. A lot of them doing, much kind of the same thing, but really wanting to integrate with their own environment. So I think things like Storm and Snowzone, I think, were more popular at the time. But those were really kind of a lot more heavyweight and a lot less easily integrated with, whatever your environment was. So having kind of seen that, having seen what people were doing, their consumer and the producer over and over again, Kafka Streams is born, which basically does exactly that. It's a wrapper around deploying Kafka clients, and lets you kind of do a lot more powerful things and don't have to worry about all of the kind of icky parts underneath, like the rebalancing protocol, where you run into that. Things like, state, persistence, all those fun things. All right, thank you. And if we could pass this over to Holden now. So Apache Spark popped up shortly thereafter as a technology. As you said, it came from a different direction, right? From the Bash world first. But what were some of the key technological considerations that came into play during its inception, and then also with the streaming aspect of it?
Yeah, so I think early Apache Spark had a lot of similarities to some Google technology, Flume Java, which is distinct from the open source namespace collisions are fantastic. And so it took a lot of inspiration, I would say, from these functional APIs. And I think it came out of a lot of frustration with the limitations of the MapReduce APIs and also the sort of speed of batch processing. And the idea was largely like, hey, there's a different way to achieve resilience, right? Because what the big problem often is in distributed computing is that the chances of a failure of one computer is not too high, but when you add 1,000 computers, the chance of a failure of one computer, it quickly gets close to 1. And that's bad. And if the failure of any single computer causes your entire job to fail, then you will be spending a lot of money on computers. We can fix this with software. And so instead of relying on reliable storage, it just relied on recompute. And that works really, really well in the batch world and not so great in the streaming world. And so quickly some things were added after the fact so that like you can keep track of watermarks and things like this. And the idea is like not everything can just be recomputed for free. Time travel has a cost. It's not like hot tub time machine level cost, but it is like back to the future level cost, I would say. And yeah, so I would say Spark sort of came at this resilience from a different sort of perspective than existing processing technologies had taken, and then sort of had to tweak this a little bit to add support for streaming data, where the recompute is a little bit more complicated.
Great. And so if we could pass the mic now to Gordon. So because a little bit after that, we had Apache Flink. And so Gordon, what specific needs was Flink as a technology trying to solve for when it was first created?
Well, if we're going to talk about when it was first created, that was like way back ago, 10 or 13 years ago, when it was a few PhD students working at TU Berlin, Technical University of Berlin. And at that time, very interestingly, it was actually trying to solve the batch processing problem, right? And so PhD students were doing database research and realized, hey, we actually have quite a bit of, from traditional databases, a lot of the streaming pipeline execution techniques, but it wasn't really being used in batch execution, and that could actually improve things. So it started out actually as a batch processing system, but it was built on top of a streaming pipeline execution engine. That makes sense. And it wasn't really after that. So at the time, when it was still a research project, it was called Stratosphere. And then after that, it was donated to Apache Incubator and became what is known as Flink now. And after that, the Flink traders saw a need in the data engineering space, which we needed a streaming system that didn't have the inherent trade-offs of latency and throughput with micro-batch systems, that based on micro-batch systems. And second of all, was also a streaming system that provides stateful capabilities with exactly one's guarantees. At the time, that wasn't available yet. And so the Flink traders just realized, hey, why don't we just expose that same execution engine with a streaming API for users to do real-time streaming applications? And that's when Flink really took off. That was like version 07 up until 1.0, where the whole Flink checkpoint layer exactly once Flink was fully.
Great. I'm going to pass it off to Matteo. All right, so Pulsar, the new kid on the block.
Yes.
And so by the time, as you mentioned, but it's more of a comparable technology to Kafka, right? But so for Pulsar and more recently Pulsar functions, can you explain more about what made you stand out as a technology?
So yeah, Pulsar is raising about actually started in 2012 in the Java. So and we really had two big problems. One was how can we build a messaging platform as a for huge platform like distributed databases, log applications, and all kind of big systems. And the other point was that you had hundreds of products that each of them they were setting up their own messaging systems. RabbitMQ, their Kafka, their ActiveMQ, whatever. There was something in Java. So essentially, what my biggest problem is kind of build a single platform that we could use that doesn't want to tell the service. So we have one team managing you, one thing cluster, and in many use cases, scale it up and use economies of scale about the SREs and the hardware. And deploying the data centers with feedback verification and those kind of things. So it was a big part. We started out and with Russia, and then we went to open source in 2016, and then it would become again to Apache Foundation and so on. And around 2018, we started this host function, then a component of the Pulsar, and the main motivation is that the water agreement to keep it's very complex. It's already there. They're only method with that very well. Want to focus on the kind of like the 80% of these cases that are not needing the full blow semantics and power of these focus solutions. So and what it was making it in a much easier way that like Kafka Streams is a library. You always say we will link it from opposite directions. It is a system that you provide the code and we run it for you. And we can model it for you, and you don't have to worry all the runtime. You don't have to worry about where's the code running. We take care of that, and there's a cluster, and that's the ability.
Perfect. If you could hand the mic back to Sophie. Okay, so again, I think it's great to have that sort of historical context whenever you're making any sort of big architectural decision, when you're building any applications. So I hope, just keep that with you, please. But now let's actually get back to the technologies at hand. So we kind of completed a lot of this from, your intros and the history lesson. But now I'm wondering, if you can give like a 1 or 2 point answer. Let's make it quick, maybe. Where does your technology excel? Okay, what do you think its best quality or qualities are?
Yeah, I think Kafka Streams is really like the way to run kind of lightweight services, whether you're building like a microservices architecture or you're just an application developer, and you want to chain a bunch of logic together, or you want to integrate with your environment. It's really flexible. You're completely neutral. Sometimes that's a good thing, sometimes it's a bad thing. But if you know what you're doing, or you have support out there, and there's great support, I think it's really like the best way to, kind of do what you want with the technology, whether that's talking to other Kafka Streams apps or just integrating with other parts of your environment.
Okay. We pass it back down to Matteo. Same question.
For Pulsar, I would say that the main differential for me is that it's bringing the traditional Kafka and all these feature-rich semantics, and but it's embedded in a scalable way, it's scalable, performant, and like way. And so it's being able to get the performance without compromising the semantics and feature set. And
Okay. Hold on.
Cool. I'd say the place where Spark kicks ass is the place where you want to do the same computation both on streaming data and batch data. This is a pretty common use case in a lot of situations for like later writing data and all sorts of other things that can be complicated to handle and can cause arbitrary state expansion problems when you're working with pure streaming sort of solutions. But if you really have a pure streaming problem,
Gordon, Silas Flink.
She actually helped me solve it. So add on top of that, I would say for Flink, because all stream processing systems like Kafka Streams, Spark, we can all do stateful computations. I think for Flink, one thing that really excels is that on top of stateful computation capabilities, it provides the users with state management operational features. For example, there's a lot of, I'll just point out one on top of my head, state pointing. That's super important. Why is that important? Because you want to be able to take a consistent snapshot of the running pipeline, and you want to take it down, planned or not planned. And let's say it's planned, and you want to be able to do your cluster upgrades, evolve your logic, which is going to happen since that this pipeline is running 24/7 all year long, right? So at some point you have to take it down, do some schema evolution or business logic evolution, or even just to rescale your pipeline to higher throughput. And you can all do that with a save point. You set a save point and then do a stateful migration so that there's seemingly no gap in your computation when you do this. The second of all is also Flink is just kick-ass in how it does its checkpointing. Checkpointing is a thing for fault-tolerant, and Flink really does this super, super well. The first checkpointing algorithm, we call it a synchronous snapshot barrier snapshotting. And this has been around ever since Flink 0.9. But ever since then, the same technique is there, but we really fan tested it and did a lot of enhancements to it. For example, we go into the details there, but things like underlying checkpointing and local task discovery, all of that to make sure that we have the least amount of synchronization barriers within the synchronous checkpoint on the job, so that it's as efficient as possible.
You're going to keep the mic. And so that was a hard sell on checkpointing, and that's great. But on the flip side of things, where would you say, I'm so sorry, I'm challenging you here, where would you say Flink falls short? Are there any gotchas that you would love to see fixed or, hurdles that folks should know about?
A lot.
To be honest,
It's always the same level system. Third down, with the complexity of Flink and the capability that it has, naturally, it can admittedly be a hard system to operate in production. There's a lot of moving parts compared to other systems like Kafka Streams, where you just have a Kafka cluster and you deploy application. With Flink, there's a lot of moving parts for you to achieve all that what I've just said. For example, you need a zookeeper for Kubernetes etcd to be able to handle your metastore. And then you need a separate remote blob storage system to be able to hold your checkpoints, right? All of that is required. And from a user perspective, I would say the biggest pain point, which I still feel today, even myself, is that Flink API is very powerful. There's different layers to it. At the very top, you have SQL, which is less error prone as a user. But as you go from a level down to a very bottom, so process functions, you have all the access to things like watermarks, checkpoint handling, event time, timers, all of that. Then there's some bottom ways for you just never know of it. So it's a very powerful API, but you have to be careful with it. And I myself actually am guilty to have caused several issues on my own when coming to these APIs.
Appreciate the honesty. All right, Holden.
Yeah, so I would say Spark is also operationally a challenge to run. Part of it is I was on call until 9 o'clock in the morning today, so I am remembering the operational challenges of the past 7 days. All kinds of fun. Which one is more operationally complex? I don't know. Right? I don't personally run a Flink cluster. My colleagues run the Flink cluster, so who knows? But I think neither of us are the easiest applications to deploy in the world, which is great. It means I have a job. On the downside, it's great, and I have a job. Whatever. So some other things that said about Spark, right? I would say Spark has a very expressive API. We do not make it clear when you're about to shoot yourself in the foot. We give you all kinds of things. Some of these things look super safe, but if you even in Spark SQL, right? If you write a lag function, there's nothing telling you that unless you add a petition by inside of this lag function, it's going to coalesce all your data to a single node. You just plan that out at runtime. And that is what we describe there as done. So there's that. And the other thing is also realistically, if you're comparing our systems, I think Spark is really great and super lovely, but if you're just writing pure streaming, we're probably not the folks for you, right? We're really excelling in the place where you've got sort of a mixed architecture. You want to run some streaming with some batch. You should also buy my book, High Performance Spark. Love this. It's one person likes it. We're making a second edition, which is actually going to talk about a lot of the places where streaming explodes. It's not finished being written, but that should not stop you from purchasing it with your company's credit card. If you do not have a corporate credit card, come find me afterwards. I can hook you up.
Mateo, all right, tell us where functions fall short.
There's a bunch of, for me, it's a SYNC, which is good. It's also SQL, which is kind of bad. And with that, I think that you cannot complex background there. And other thing that we also wanted to do and stuff we do is for around versioning and kind of like A/B testing of functions. That is something that is really something that I would like to see in there for and integration with the CI, for example. Like that's something that is sure you can use the API and submit your functions and update them, but you don't know which version is running. Very difficult to see which version of your code is running, and also integrate directly with your CI process.
Sophie.
Cool, yeah. I mean, I've been on call before. I can tell you all kinds of things where Streams is going to start to fail, but I think, most people could probably name the two things that are the biggest problems for folks running Kafka Streams. That would be rebalancing and restoration, or, restoring your state from a change log topic in Kafka. Unlike having, we don't have checkpoints or anything like that in Kafka Streams. You just have your local state, which makes it fast, but also means if you're, scaling it out, things like that, you have a hard crash, you lose your state, can need to restore it from scratch. That could be a pretty long downtime. I think there's a lot of room to grow there. I don't get the fundamental limitation, but that's certainly a pain point in people's stand. On the other hand, the balancing, and it's one of the biggest strengths is also the biggest weakness at times, which is the close coupling with Kafka. So if something is going wrong with your Kafka cluster, you're going to have issues with Kafka Streams. And vice versa can also be true. People get really frustrated with balancing. There's been a lot of issues with it. Sometimes you just get stuck in a loop. We've also made a lot of improvements recently, I would say, and sometimes you just really need to upgrade to get that bug fix or improvement, and people don't always want to do that, and I understand it, but it can be hard to support complicated protocol like the balancing across 2-year-old versions. But we're happy to do it.
All right, so we saw some pros, we saw some cons. Maybe with some of those cons in mind, are there any features that a user can expect to see on the horizon that would maybe be a game changer for your technology? Yeah, go for it.
Cool, yeah. I think there's always something out Kafka Streams. I think some of them are just kind of table stakes, like people probably are familiar with exactly what semantics. Kafka Streams supports this, but right now it's kind of a trade-off that you have to make between performance and semantics. So we're really committed to making work a lot better and closing the performance gaps so that we can ultimately enable that by default. So you just get perfectly tight semantics out of that. I guess the other two things, like I said, there's the rebalancing and there's the restoration. On the rebalancing side, kind of had a full-on very well refactor in the works for a long time that we're kind of starting to nip at the butt of. And we're that will help to head off a lot of the rebalancing issues and a lot of the scheduling and task assignment issues by basically decoupling the Kafka clients as well as the actual processing threads. On the other hand, there's restoration. I think you'll have to come talk to me after this to hear more details, but there's two things that I'm excited about. They're both proprietary, not quite open source. First one is on the company. I don't want to spoil the surprise, but there's basically a drop-in Apache 2 replacement that speeds things up. So if you're going through restoration, it'll go faster. On the flip side, there's my company, which has a state source, so you basically don't have to go through restoration at all. I'm happy to tell you more about either one of those or point you to the other company, but they won't take their announcement.
Deo, what do we have coming?
Sure. On the Pulsar side, we have many initiatives throughout the spectrum there, but mostly around making Pulsar available more scalable and scalable in a way that dimensions fit up in a number of topics. And that's something that the idea is that we want to make sure that developers can design applications in the most natural way for the business domain. And so if you have if you see events for users, then you should be able to use software for user. You should know design your application with the limitations of the underlying platform, and because that will make it much more complex. Now you have to fight exactly that class, and we lose visibility, we lose characterity. So we have already weeks of millions topics, but we want to do 100x more, and being able to just make that as a visual thing, and something that you don't have to think about.
Right, hold on.
cool. Mine are going to be basic in comparison. Like, we're doing all kinds of full technology things, but I think the like most exciting thing is making our error messages suck less. Good. Thank you. I'm assuming that those claps for help from people who've had to run the they are terrible. And we are going to make that less terrible. And that is the thing that I'm most excited about. Also, like Spark 4, whenever that'll come and landed milk and honey, et cetera, et cetera. But the main thing is the error messages we intend to be readable by humans.
I'm trying to think of a very specific one. So when it comes to improvements, the ones that I like best are the ones that just remove the user having to make choices, as it also supposed to make the right choices, but that's not always the case. So there's this specific choice in Flink where you can choose between an in-memory state backend to hold your runtime local state. There's also the RocksDB state backend. And usually users have to choose between these two because for the in-memory state backend, it's very high throughput, but you might have a potential to fuck into ORF issues or just performance degradation. And on the other hand, from the other side, you could also trade off for lower throughput, but just for more reliability by using RocksDB state backend to back up your state. Now, there's a Vietnamese Flink improvement proposal. We kind of borrowed the name from Kafka kit. But that proposal basically adds this proposal to add an ARM cache on top of to work with the RocksDB state backend. And theoretically, we should give you asymptotically the same throughput as memory state backend, but you have a nice benefits of an off-heap state backend as well. So that's a good thing. And if we're talking about that in the long term, like Flink 2.0, we're in the very, very early phase of planning that. The one thing that I'm most excited about is finally fixing the APIs that Flink provides so that it's much, much less easy for users to step on their own foot, like I've talked about before.
Nice, cool. Okay, so thanks for that, the sampler from all of you on what's to come. So we're getting close to we've got not too much time left, so we're gonna have to do like rapid fire for the rest of these. All right, are you ready? Okay, cool. So, this is meant to be a sampler for you all if you're trying to decide which technology you want to be using. So a big deciding factor in that is like, what technological landscape do I need to have to support running this technology, right? What do I need in my tech stack? What am I going to have to maintain to make this work? So if we're going to go, what do we need for Flink?
Yeah, so as I said, Flink has a lot of parts. One of besides the job manager, task manager, distributed runtime, the Flink cluster itself, you have to first decide what deployment mode you're going to deploy this, and this largely depends on your company's existing infra, how you're going to run Flink jobs. Then on top of that, you also have, as I mentioned, Zoomkeeper and if you're using Kubernetes, Kubernetes etcd to handle your metastore for your Flink job. And then you have to decide, okay, do I use, based on your cloud environment, you could be using S3 or Google Cloud Storage for your checkpoint storage. So there's a lot of moving parts, and on top of that, you also have to decide, okay, which external things and sources that I need to participate with our Flink pipelines, and make sure they're configured properly. Transactional stores, you have to configure them properly to be able to work with Flink's exactly once. But if we're talking about just like getting started and writing your first Flink pipeline, it's pretty easy. It's not that complicated. You can just open your laptop, open your favorite IDE text editor, write a simple Java program, import Flink dependencies, and run that program so that you have a mini JVM cluster, a mini Flink cluster running within the same JVM, let's say your IDE, and you're running a Flink job there. So I'm just saying the different levels of stuff that needs to get working Flink job.
All right. We really need to settle on a definition for rapid fire here. So hold on.
Yeah, you need a cluster and storage.
Ooh. All right. Okay. We can find some happy medium in there, I think. No, keep going. Make it fast. Go.
So, Pulsar, we have one of the dependencies, Zookeeper, and in the past couple of years, I've been working on a solution to replace Zookeeper as well. And we have open source a few months ago a new system. It's called Oxia from Significant, and it's can see that it has a horizontal scalable sleep, which we use for this combination and with data, but it's kind of like and just add more nodes and more capacity.
Great. All right, I'll keep things short and sweet and not gloss over any details. With Kafka Streams, you need Kafka and DU, and you can run it however you want. That's all you got.
Simple, short, sweet, to the point. Okay, in one sentence, what advice would you give someone who wants to use your technology for the first time? There's one thing they can take away here.
Just try it out. If you already have data in Kafka already, take a look at it. The more that you look at what you have like with Kafka servicing other needs, the more you'll find something interesting to do with it. That you can do with Kafka Streams.
Spokes, details.
Say, can try Pulsar on the laptop and try all the features out in the box from messaging, storage, and compute, and then the leap to cluster is very easy.
Yeah, just run it. Also buy my book.
Shameless plug. We have a Flink training course on the Confluent developer website. I would say check that out. That's probably my pick.
Okay, we've got, again, one final question, and I want to stir the pot here right before we let everybody go. So, if you suddenly weren't allowed to use your technology that you represent here today, and you could never use it again, which other streaming technology or stream processing technology would you use? If it could be one of these, if it be something else. It depends on
Use case, I guess, as all four things are.
what is developer answer? It depends.
So if you already have the Kafka cluster running, right, and what you really want to do is you want to just embed stream processing capabilities into microservices, I would go with Kafka Streams. But if you want to go to the other extreme with very powerful data analytical workloads on stream processing, on real-time streams and also historical data, and you probably don't mind the extra latency that might be involved with micro batches, I probably just pick Spark streaming. But if you do really care about streaming and I can't pick Flink, there are other very interesting systems that are coming up right now. Things like Rising Wave, Arroyo, these new systems that are coming up. I haven't really took the time to look deep into them, but that will probably be my next best.
Right. It depends as well. Probably Flink, maybe Fight Blacks. I'm playing with Ray. It's pretty great, but it's streaming imputation. Yeah. YOLO. But, I get paid to operate software, and I will break a lot, so I'll do that.
They invited new system.
Yeah, I'll skip the whole independence thing because I was waiting to cover my views on that. I guess, I don't know, I'd probably just start writing with the plain Kafka consumer and producer again, so flexible as you always say in great stuff. I guess they just build Kafka Streams again, but maybe in a different way, but just, yeah, I totally started the question, but that's great. I love it. All right. We're about to be kicked out, so you can find any one of these experts out, the next 2 days. So please go ask them your burning questions. They're here to help out with into further to use their technology. So great job.